Okay, now we're done with chapter or section 2.5. We're going to move into section 2.6. This one's not as long as 2.5, but this one deals with applications. And basically, with all the problems that you do, it's a 6-step process. So, for all these applications or solving any of these problems, and I'm mainly talking about word problems and things like that, you're basically, first thing you're going to do is always read the problem. And when you read the problem, the whole point of reading that problem is you're going to list your knowns and your unknowns. And your unknowns are generally what you're trying to solve. That should be kind of your focus. Then the second thing you're going to do is you're going to assign a variable to the unknown. And remember, like I said, that's generally what you're trying to solve for. So you're going to assign a variable for your unknown. Third thing you're going to do is then you're going to translate the other information or the other info. I know what you're thinking, like translate it. What does that mean? Well, I'm going to kind of explain that a little bit. But number 4, always go back through and just reread. Make sure you didn't miss something, skip something. Like I said, people's names and all that kind of stuff. I mean, they just kind of help you assign variables and things like that. But generally, we're just focusing on the numbers. Fifth thing you're going to do is solve, and and basically notice that I say you're going to solve your equation because you are going to make your own equation based off the information that you're given. And number 6, you're going to check your solution, and that always comes with a caveat of if it's if it's time providing or even if it's applicable. So if you have a ton of fractions or decimals, obviously it would be more time consuming sometimes to go back and actually check your solution than it is to even solve the equation. So that's not always feasible. So anyway, this is basically your 6-step process. Follow this. You're going to be very successful with it. But more importantly, we're just going to go over what our conversions are. And what I mean by the conversions are things that kind of clue you in to where how you translate it, which was number 3 on the problem solving. So the first thing is anytime it says the sum of, and I'm just going to use like A and B, right? So you're just going to list A and B. These are generally going to be numbers, but sometimes they're knowns and unknowns. The sum is just telling you to add. Now this is also interchangeable with the total or the overall or anything like that. Anytime you see sum, it's just basically telling you to add those two things together. Anytime you see the difference, it's telling you that that would be A minus B. Right? And mainly these would be numbers, but anyway, the difference, right? It's just telling you to subtract. If you think about when we had the problems for you had a checking account and then you withdrew some money, then that was the difference, or you took it away. Anytime it says the product, that's telling you to multiply. But I'm not big on using that because that's not a word you hear every day. And then there's another one called the quotient, which is basically telling you to divide A divided by B. I'm not big on these words, so you probably won't see them in any of my word problems. But moving forward, you may see them in some of your upper level math classes. But generally, anytime you see of, just like with our percentage, not always, but 99 times out of 100, it's telling you to multiply. You know, and then almost always when you see the is, it's telling you that's where you're going to be equal sign. That's not just for those percentages; it's generally for these also. But anytime it tells you what is something, or what is a, or what is, anytime it's giving you a what, that is almost always what your variable or what your, more importantly, what your unknown is. Now, you don't always have to pick X. I generally pick X, but if it's like if we're talking about apples, then I would pick an A and let that represent my apples. So, but whatever works for yours. Anytime you see something that says 4 more than X, so 4 more than X is just written out exactly, kind of the way you see it. 4 more than X That means I have x, and then I add 4 to that. So that's telling me it's 4 more than x. If it says 4 times x, then that's just telling you it's 4 multiplied by x, or 4x. If it's telling you that it's 4 less than x, once again, it's kind of the opposite of that. It's just x minus 4. So just pay attention to what it's asking you to do. And then I'll kind of go over some examples. So here's an example of that. If it says that the sum, I'm going to abbreviate sometimes when I write, but anyway, the sum of twice a number, and I'm just going to abbreviate that with a number sign or the hashtag, of a number and 3 is 7. So once again, we're going to read the problem, the sum of blah, 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 right? We read it. We're going to go and assign so a number, which is something that we don't know, that's going to be our unknown. So I'm going to just pick x for that. I'm going to say that's going to be my x. And then I'm going to write it out exactly as I see it. It says the sum of twice x, right? Or twice a number, which I know is going to be twice x or 2x. So I know that 2x is going to be my number. And then it says and 3. So my 3 is going to be my next number. Is going to be my equal sign, and 7 is going to be my last number. Now, anytime I see an and, it's either going to tell you the sum, the product, the quotient, or the difference. Generally in my class, it's always going to be the sum or the difference. But for the sum, it's just telling you that is where you put your plus sign. Now, if I convert this over, now it's just basic, right? We've done that a ton of times. So I'm going to solve it just like with anything else. Numbers on one side, letters on the other. Allows that to become 2x. 7 minus 3 is 4. Divide both of these by 2. That allows that to become a single x. Divide 4 by 2. And 4 by 2, or 4 divided by 2 is going to give me 2. So then I'll just go back and I'll just kind of check this. If I take 2 and I multiply it by, or twice, so 2 times 2 is going to give me 4. If I add or sum or add 3 to that, is that going to give me 7? Yes, it will. So that's a quick way that you can kind of go back and kind of check that. So if we just use another one, let's say that a number, and once again, I'm just going to abbreviate here. A number is 3 times, or is 3, let's just say 3 more than twice another. Kind of run out of room there. And their sum is 18. So this one's kind of long, but that's fine. Process is going to be the same. So once again, if I'm writing that, it says a number, which is what number or something you don't know. That's going to be your unknown. So automatically, I'm going to assign that as my x. So x is, it's going to be my equal sign, 3 more than twice another. So let's just kind of look at that one, another number. So let's try to kind of break that down. These numbers are going to be the same. So twice another is going to be 2x. So that's going to be my 2x. And then it says their sum, 3 more. So remember, their sum is telling you that's going to be added. 3 more than that is going to be my 3. And it's going to tell you that all of that is going to be equal to 18. Now notice that I've got 2 equal sign here. So I need to address that. So if it's telling me that my sum is going to be, that is now is not really that's not really where my equal sign is, because I can't solve an equation if I have 2 equal signs. So that means that it's telling you just to add all of that stuff up. So I'm going to replace that now with an addition sign. Now, if it didn't say is 18 out here, then we would just leave that in there. So if I add these together, I have 1x. I'm just going to put a 1 there just so it helps me, keep them straight. So 1x plus 2x, these are like items, so I can add them. That's going to give me 3x. 3x plus 3 is equal to 18. And then once again, letters on one side, numbers on the other. That's going to give me 3x is equal to 15. Divide both of these by 3. And that's going to tell you that x is equal to 5. So if I look at these again, is a number, it's 5. And then I'm going to just kind of work this out. 3 times 5, or 2 times 5 added to 5 is 15. Add that to 3 is going to give me 18, right? So anyway, most of these things are written out to give you way more stuff in here than this. And what I mean by stuff is just filler. So people's names and places and things like that, those things are just fillers in a question. So when we work these out, I'm going to keep mine somewhat simple. And what I mean by that is I'm going to just show you one more example. And one more example is, once again, I have Sheila. And Sheila has 25 pieces of fruit. And she has 7 more apples than oranges. And then basically it wants to know is how many of each does she have. So once again, we're going to list our knowns and our unknowns. So what we do know is total fruit is equal to 25. And we know she has 2 types of fruits because we have apples and oranges. So I'm just going to go ahead, and the one thing that we don't know is it addresses apples. It says you have 7 more apples than oranges. So we know that apples is 7 more than oranges. What that means is we don't know what an orange is. We don't know how many she has. So that's going to become my variable. So I'm just going to make this orange. I could make it a no, but I don't want to get confused with a 0. So I'm just going to make that my y. And then I'm going to address my apples. So my apples, it just says that I have 7 more than oranges. Well, that's just going to be y plus 7. Simple as that. So now all I have to do is kind of write this in. So I know that my fruit, or my total, is going to be equal to adding these together, which is going to be y plus 7. Well, I already know that my fruit is going to be a total of 25, so all I'm doing is just substituting in my total. 25 is equal to y plus 7. Now I'm going to go ahead and put a 1 in front of these just so when I add them together, it'll look right. 1 plus 1 is 2, so that's going to be 25 is equal to 2y plus 7. I'm going to solve this just like anything else. Numbers on one side, letters on the other. Letters are already on this side, so I'm just going to move the number to the other side. The opposite of positive 7 is negative 7. That's going to give me 18. Remember, that just disappears. 2y is equal to 18. Divide both of these by 2. And y is going to be equal to 18 over 2, which is going to be 9. So I know that my oranges, I'm going to have a total of 9 oranges. Now, how do I know how many apples I have? Well, I just substitute that in. That's going to be 9 plus 7, because all I'm doing is just substituting a 9 in for the y. 9 plus 7 is 16. If I add both of these together, 9 plus 16, carry the 1, it's going to give me 25. I know that she had 25 pieces of fruit, so I know I've worked this out correctly.